Okay, so we're now going to look at another energetics topic, calorimetry. In calorimetry, we use the changes in temperature to be able to work out the enthalpy change of a chemical reaction. We use the formula Q equals mc delta T. Here, Q represents the energy which has been either released or absorbed in the reaction. M represents the mass of the liquid being heated. This is often water. C represents the specific heat capacity. And because it's normally water, we normally see it as a constant value of 4.18. The units I'll tell you in a second. And finally, we have the change in temperature. Okay, so the units for energy for this process are joules. The unit for the mass of liquid which we're going to use is grams. The temperature is often measured in degrees Celsius, or it can also be in Kelvin. It doesn't matter really because they're both interconvertible. And finally, the unit for the specific heat capacity is joules per gram per Kelvin or per degree Celsius. Okay, so for simplicity, I'm just going to put joules per gram per Kelvin. Okay, so once we've worked out the energy of the reaction, we want to work out the enthalpy change of the reaction, delta H. And delta H is measured in kilojoules per mole. So the first thing we'd want to do is take our value of Q and divide that by 1,000 to get our unit into kilojoules. And then finally, we would then want to divide it by the number of moles being used. Okay, so that's the basic principles. At the end of the process, we might then need to decide on the sign. It could be positive or negative. If the value is positive, the reaction would be endothermic. If the reaction is exothermic, it will be a negative value. Okay, so we're going to use this bit of information to now carry out an examination question. Okay, so the examination question states that a student carried out an experiment to determine the enthalpy change when a sample of methanol was burned. The student found the temperature of 140 grams of water increased by 7.5 degrees Celsius when 0.011 moles of the methanol was burnt. Okay, use the student's results to calculate, here's what you need to find out, calculate the value in kilojoules per mole for the enthalpy change when 1 mole of methanol was burnt. Okay, so Q equals M times C times delta T. Here, the mass that we're going to use is 140 grams. We've been told the specific heat capacity is 4.18. And finally, that the temperature change is 7.5 degrees. Okay, so if I use a calculator, we get an answer of 4,389 joules. Okay, so what do we need to do now? We want to work out the enthalpy change of the reaction. So we now need to work out delta H. Delta H equals the value we just worked out, Q, which would be 4,389. And we're going to use the value in kilojoules per mole, so we have to divide that by 1,000. And all of that is then divided by the number of moles. The number of moles already given to us, which is 0.011. In some examination questions, you would have to work out the number of moles because they'll give you a change in mass, and you'd have to use a relative molecular mass to work out the change in number of moles. Okay, so if I take this now, and I can now work out delta H to be 4,389, divide by 1,000, get my value into kilojoules, and then after that divide by 0.011. So we end up with a value of 399. And that is our unit. So 399 kilojoules per mole. So if we go back to the question, it says there was an increase of 7.5 degrees. An increase therefore tells us it's an exothermic reaction, so we need to put a negative sign. Okay, so let's have a quick look at where the marks are going to be, thinking about the fact that this is a 3-mark question. So firstly, you would get 1 mark for stating this equation here, Q equals M times C times delta T. There's 1 mark there, or you would get a mark for putting the numbers in, either or. You then get a mark for calculating the value here at 4,389 joules. Finally, you'd get a mark for the overall calculation, so delta H equals this, and that's your 3rd mark. Now, people can lose marks, simple marks, if you either give the incorrect sign or you incorrectly put the wrong unit.